So this section is on the measurement of body composition because, again, the weight for height indicators don't tell you what the body is actually made of. Because in the case of people who have a large muscle mass, they could be considered overweight when they aren't actually over fat. So with body composition, we have techniques to measure the percent of fat and lean tissue in the body. There's lots of different methods. Some are more accurate than others are. One of the common methods, because it's not very expensive, the equipment is not expensive to do this, is skin fold testing. What you do for this is you measure the thickness of skin folds with calipers, typically at 3 different sites. And you add up the sum of those skin folds, the sum of the thickness of the skin folds, and look that up on a chart, and you see what that skin fold thickness sum, what body fat that thickness skin fold sum corresponds to. Now, this is real technique dependent. You have to be well trained to do this to get the right type of pinch. You don't want to pinch up some underlying muscle tissue with that fat tissue. Also, I'd like for you, because y'all are young, to take a second to try and pinch up a fat fold from your thigh. Okay, what you'll find is it's hard to get a really good fat fold from your thigh when you're young because your fat is really firm and seems to adhere to the muscle underneath. The older you get, the easier it is to pinch the fat away from the underlying tissue. So the person has to be well trained, and usually we have them compare what they get when they're training. We compare the values that they get for percent body fat to one of the gold standard methods to make sure that they're accurate. People who are obese and people who have fat depositions or fat that's unevenly spread throughout their body can be really inaccurate for them. So you shouldn't measure body fat with skin folds for obese people. And people under about 3% body fat, it won't be accurate for them either. But if somebody's really good at this type of testing, they can be accurate within about 3%. Okay, again, 3% error is enough to put a person in a different classification. Say you measured the body fat of a man with the skin folds, and he came out to be 26%. That puts him in the over fat category, when if you measured him by one of the gold standard methods, he might have been 24%. So these are the calipers. You can see the pinch of the fat fold that the caliper actually measures. There's some better calipers than others, and there's a caliper that actually adjusts for the person's age because, again, depending on how old you are, it's easier to get a pinch. So there's calipers that adjust for a stronger pinch for younger people and a weaker pinch for older people because their fat's more compressible. There's a website at the bottom here, and I've indicated the 3 sites that are tested for men and women, and it's indicated on that person's body. You can go to that website and get more information on skin fold testing. Now, underwater weighing used to be considered the gold standard. It's also called hydrostatic weighing. It's not really anymore. It really varies on the dunk tank that you use. Some are really crude and difficult to use, and some are very high-tech that have built-in technology to account for the movement of water. But what you're actually doing when you dunk someone underwater and measure their weight underwater, you compare their weight underwater to their weight on dry land, and there's an equation you can plug that into that will determine their body volume. And if you know a person's body volume, you can determine their body density. Okay, so someone who has more fat will weigh less underwater than they do relative to their weight on dry land because fat floats. If you ever go to the ocean where the water is really salty, you know that if you have a lot of body fat, that it's really easy to float. So weight divided by volume is body density, and since you can get the person's volume when you weigh them underwater and compare that to dry land and plug it into the equation, you can calculate their body density, and from body density you can easily determine a person's percent body fat with another equation. So here's an explanation of body density, weight per unit volume. So if something weighs a lot for a given volume, it has a high density, and muscle per unit volume weighs more than fat. If something does not have a lot of weight for that same volume, it has a lower density. So in a human being, that would indicate a greater amount of body fat. So these two boxes are the same volume. One weighs more than the other. So the one that weighs 175 has a higher density, higher lean mass. The one that weighs less, 150 pounds, has a lower density, and that would represent a higher percent body fat. The accuracy, like I said, depends on the technique of the person you're dunking. They have to blow out all of their water because air floats. So if they don't blow out all of their water, it will make them seem like they have a lot higher percent body fat. I did have, I was doing a study and I had to measure people's body composition, and they weren't blowing out all of their water or their air underwater. And so I had to get my graduate student who was really good at skin fold testing come in and measure their body composition. If a person has osteoporosis, it will also be inaccurate because it will make them look like they have more body fat, less lean mass. So there's some videos on hydrostatic weighing. This first one, I'm going to see if I can pull it up. I had a little trouble yesterday with this. You can kind of see that. This is they're trying to get him to blow his air out, and you can see they're trying to get his weight underwater. There we go. And you could see that scales needle was moving, and the people who were doing it had to figure out how much he weighed underwater. So that kind of crude device makes it more difficult. Now this video, I'm not going to show the entire thing, but it shows a more sophisticated device.
Hey, we're here at Fitness Wave, and we're about to get hydrostatic weight, which is a measure of body fat. It's actually kind of the gold standard of body fat measurement. What it does is really simply, it's a principle that was figured out by Archimedes years and years ago.
So you can see that he still had that, needle scale behind him, but that device that he had, the person actually lays down underwater, and there's some technology that kind of corrects for the waves that are created with movement. And it's really not considered the gold standard anymore. The bod pod is a way, and the bod pod is really accurate. It measures body volume by determining the amount of air a body displaces when it's in that pod. Now, in that picture, that guy in the picture should be wearing a hair covering or a swim cap, because you have to wear like a really tight-fitting swimsuit or swim trunks when you're having that done, because that can affect the measurement. So there's a little bit of a technique error there. At the bottom of this slide, there is a link to a YouTube video that shows somebody actually having their body composition measured in the bod pod. But instead of being dunked underwater, there's some technology where you can sit in this capsule type thing where that determines your body volume by determining the air displacement. So the technical term for the technique is called air displacement plethysmography. It's accurate within 2 to 3%. The problem is, and you do find it sometimes at high-end fitness centers, it's about $50,000. I use this for research, actually. This was one of my pieces of equipment at one school. Near-infrared interactants, I'm not going to talk about that because it shouldn't be used. It was actually adapted from a technique that was used to determine subcutaneous fat for cattle, and it's not accurate at all. They just look at the scatter of light at the bicep, and that's not representative of your overall body fat. So we're not going to talk about that one. Bioelectrical impedance is used quite a bit. There's lots of different types of devices now. And what it basically does is it measures the amount of time it takes for a current of electricity to get from one part of the body to another. Lean tissue tends to be high in water. Fat tissue does not have very much water. So fat tissue does not conduct electricity very well, and it'll take longer for that current to get from one part of the body to another. And that's kind of how it predicts percent body fat. But it's not very accurate with people with fluctuating body weight. If you're dehydrated, it will overestimate. So here's a picture of electrodes that are attached to the foot and the hand in one of the for one of the types of bioelectrical impedance techniques. It can be accurate within 3%, but it's dependent on the person's hydration status and the device that's used. There's lots of different devices for measuring body composition. The ones that run the electrical current from the foot to the hand are the most accurate because the current goes through the body. The ones that just go from foot to foot, those scales that you can stand on, that one right there, are not as accurate because the current just goes through the lower body. This one I've done research with. It's not very accurate at all. You hold that device in your hands and hold it out in front of your body, and the current just goes through the top of the body. So this was a line of research that I did at one of my schools, and this was the results of one of the studies I did. And actually I was going to prop my my cell phone up on my students' theses. Okay, and one of them is this study where we compared different methods of body composition. So we had our subjects measure we measured our subjects' percent body fat or body composition using the handheld BIA. That's on the left, the arm to leg BIA, and that's the one in the middle, and the bod pod. Air displacement plethysmography on the right. And there's no significant difference between the arm to leg BIA and the bod pod percent body fat, but you can see the handheld BIA came out a lot lower. I did another study when I had a DEXA, which is now considered the gold standard in the last device that we'll talk about. I compared handheld BIA to bod pod and DEXA. The bod pod and DEXA came out the same. The handheld BIA, again, came out much, much lower. So it's not accurate. So dual energy X-ray absorptiometry, or DEXA, that's a device that is used to measure bone density to determine osteoporosis risk. So it measures lean tissue, fat tissue, and bone. Lean tissue and bone would both be considered actually lean tissue. And the basic principle is that two different low-dose X-ray levels are used to scan a person, and they look at the ratio of the absorption of the photons from the two different levels and determine body composition from that information. So this is a picture of a DEXA. To get a total body scan, the person just lays on the table and that arm passes from the top of the body to the bottom of the body. She should not be wearing anything with metal on it. It won't hurt her, but it will affect the measurement. Interestingly, I was scanning somebody. I had one of these. I was scanning somebody, and there was a perfect safety pin image, and I asked her if there was a safety pin that she was wearing, and she completely denied it. But there it was, because metal shows up really vividly on X-rays. The X-ray is so low that the person measuring does not have to stand behind a shield. It's about the amount of X-ray you'd get on a long plane flight. Another person I was scanning, you could see this really bright dot in their abdomen. That was their multivitamin mineral supplement. So the DEXA is really accurate. This is, you can adjust the image that comes up on the computer to show the skeleton or show more of the soft tissue mass. But anyway, it is really accurate. And you can actually box out regions of the body to determine determine regional amounts of body fat. It's quick, it's easy. The machine does cost over $100,000, so it's not widely available for body composition. These are the American Council on Education ranges for body fat. There is an essential amount of body fat that you need. And they break it down into a lot of different levels. What is generally used by health professionals is that about 5 to 25% of body fat is a healthy range for men. Under 5%, that could mean you don't have enough body fat to cushion your organs. And remember when we talked about lipids, if you don't have enough of that fat pad around the kidneys, if you do something like go for a long run, you could actually bruise the kidneys because you don't have that cushioning. A former student of mine, her father was on the Mexican Olympic gymnastics team, and his body fat got so low he had difficulty thinking. Your brain has a large amount of fat in it, so if someone calls you a fat head, that's actually a compliment, I guess. But his body fat got so low that there wasn't enough fat in his brain for him to think properly, so he had to gain some body fat to be healthy. Women, if they go below 12%, even below 15%, they don't have enough body fat to produce adequate estrogen. It affects fertility, and without adequate estrogen, bone health is compromised, and you're at very high risk for osteoporosis. There are other guidelines to interpret percent body fat. Some of them are just based on appearance, though. So as far as the usefulness, body composition is a good way to track changes if a person is, on a new fitness regimen, for example. It's a better indicator of what type of tissue you're gaining or losing. For some people, it is a motivator and is useful information. For other people, the numbers cause a lot of distress. I remember measuring a female, and she came out to be 27% body fat, which is within the healthy range. And she actually started to cry because she's like, "Oh, my body's more than a quarter fat." Well, that's a healthy range for a female. So as a health professional, I still prefer to focus on healthy behaviors rather than numbers. So that's it for this section. There's a little bit more left. Let's see. We'll talk about body fat distribution and genetic body types in the next section.